The first step is to move the decimal place. Okay, what do we want to move the decimal place? We can only have one number to the left of the decimal place. So this number is going to become 1.2. So 12,000 will become 1.2. How many times did I move that decimal place? 1, 2, 3, 4. I moved it 4 times to the left. So this is 1.2 times 10 to the 4th. This is the same number. 12,000 is the same number as 1.2 times 10 to the 4th. Those are totally equivalent. Again, I move the decimal place 4 times. 1, 2, 3, 4. I got 1.2 times 10 to the 4th. They're the same number, but now it's in scientific notation. Right now, we're just learning how do you convert numbers into scientific notation. Okay. Any questions, comments, or concerns about that example, about 12,000? Are there any questions, comments, or concerns about what we just did, turning 12,000 into 1.2 times 10 to the 4th? I claim they're the same number. The reason we're doing that, the reason why we're converting it, is we're just trying to learn how scientific notation works. Okay. So stop me if you have a question. All right, next one I'm going to do, and this one's a little bit tricky. 62.1 billion. I'm going to convert this into scientific notation. All right, well, one thing I want to note is that 1 billion has 9 zeros. Okay, I need to note that. So 62.1 billion, well, there's a couple rules coming in at the same time. So I need to convert this to 6.21 because it's scientific notation. I can only have one number to the left of the decimal point. So this number has to become 6.21 times 10. And now I have to think about, okay, what number is going to be in that exponent? Since this is a billion, I start with 9, but I converted it to 6.21, not 62.1. So I think it has to be 10. 10 to the 10th spot, okay? Because I had to move it one more time. This is tricky. This is something you'll see with millions and billions on the homework. It's always a trick. So if it's like 62.1 billion, you get 9 zeros because of the billion, but we had to move it one more time because it's 6.21 and not 62. Okay, I'm going to pause. Are there any questions about that? Of why it's 10 and not 9? Are there any questions about the notation, of why I'm writing it this way? Don't hesitate to stop me if there's a question. All right, let's try this one. So this number right here with the 841, this number is less than 1. Notice this is a number between 0 and 1. There's all these zeros here. Okay, so I'm still going to use the same system. I'm going to turn this into 8.41, just like I would with any other number. Okay, I'm going to convert this standard number into scientific notation. 8.41, I only have one number left of the decimal place. But I need to think about what is going to be the exponent. What's going to be that exponent? Well, in this case, I'm moving it to the right. So this is 1, 2, 3, 4, 5. Okay, so I moved it 5 times to the right. Because I'm moving it to the right, this is a -5. It's not a negative number. It's a -5. This tells me that it's smaller than 1. I'm moving it to the right. So this is 8.41 times 10 to the -5th. Okay. Any questions about that -5? Okay. Are there any questions about that? Please let me know if there's any questions. 1, 2, 3, 4, 5. Notice that there's 5. You can also just count the zeros. Notice there's 5 zeros right there. 1, 2, 3, 4, 5. Okay, we do count the 0 on the left of the decimal place there, okay? Any questions about that? 1, 2, 3, 4, 5. Okay. Any questions? Okay. If no questions, let's move on to the next one. This one's going to be similar. Okay. What am I going to end up with? 9.009 times 10. Okay, I have to count how many zeros am I dealing with? 1, 2, 3, 4, 5, 6, 7. So I think this would be to the negative 7th. Okay. There's a question, where did I get the negative 1 from? Caroline, are you asking about the 8.41 times 10 to the negative 5th? For that one, if that's what you're asking, I am moving the decimal place to the right 5 times. 1, 2, 3, 4, 5 to signify, to show that I'm moving the decimal place to the right. This is negative 5. So this is negative 5. So if a number is between, or if it's less than 1, if it's between 0 and 1, we're going to have a negative exponent. Negative exponent. Okay, and that's the same with this one. 9.009 times 10 to the negative 7. Hopefully that negative right there is showing up. This is also less than 1. So we have a negative exponent. Okay, negative exponent means you're moving it to the right. Okay. Caroline, does that help? Does that make sense? Thank you, and thank you for asking. All right, now that's the idea. So that's the idea. Why would you do this? The idea is that scientists have to deal with very large numbers, very small numbers. And so this is the system that they come up with. Again, we're not changing the values of these numbers. We're just changing the number, the way we write it. Okay, the way we write it. Another way that we change how we write things is that billion right there. That billion signifies 9 zeros. Okay, that's a way of converting the zeros into English. So this is another way. It's just a notational thing. It's just a way of writing it down. Okay. Okay, now we're going to use scientific notation to do some calculations. All right, that's what we're going to do. We're going to multiply numbers, divide numbers, divide numbers. That's what we're going to do. We're going to actually do some calculations with scientific notation. Looks like we have 4 to work with. Let's work with the first one here. Okay. So for multiplying 1.1 times 10 to the second with 6.7 times 10 to the fourth, I'm going to take this up in pieces. Okay. So the first thing I'm going to do for myself is I'm going to multiply the numbers in front. Okay. So hopefully you can see my calculator. I think you can. Okay. On my side of Zoom, it says you can see my calculator. So I'm going to multiply 1.1 times 6.7. And what do I get? I get 7.37. Thank you, Peyton, for letting me know. All right. The only thing I did was I multiplied the numbers in front. Nothing fancy. Okay. Now I'm multiplying these. They have this times 10 business. What am I going to do with this times 10 business? What am I going to do? What we're going to do is we are going to add, hopefully you can even see the zooming in business. I am going to add these exponents. I'm going to add them up. So 2 and 4 is 6. So 2 plus 4. Okay. It's going to give me my 6. When we multiply, we add the exponents. So I think my answer is 7.37 times 10 to the 6th. Let me write that just a little bit better. Times 10 to the 6th. The way I got 6 was I added the two exponents together. If I'm multiplying scientific notation, I add exponents. If I'm multiplying, I add the exponents. Multiplication, addition, very related, so it kind of makes sense, okay? So if we are multiplying scientific notation, we just add the exponents. How did we get 7.37? We multiplied the numbers in front. 1.1 times 6.7, okay? Now, if you want to be super strict about rounding, okay, if you want to be ultimate strict, this had two significant figures, this had two. So technically, we would answer our question about in 2, so this would be 7.4 times 10 to the 6th. But right now, I'm just not so worried about the rounding. I'm more concerned with how did we get times 10 to the 6th? Where did that come from? We just added the exponents. Okay, I hope that makes sense. I'm going to skip to the multiplying again, since we just did one with multiplying. Maybe the second one will make sense. Here we want to multiply 5.5 times 10 to the 3rd with 6.0 times 10 to the 4th. We want to multiply these. How am I going to do that? I'm going to multiply the numbers in front first. 5.5 times 6.0 gives me 33 times 10. I'm going to add the exponents. So that's a 3, that's a 4, that gives me 7. Okay, the first step is done. Now, what do I notice? I notice I have 33 times 10 to the 7th. And that's fine, that is the correct answer, but it's not technically in scientific notation. So I need to move that decimal place one time. Okay, I need to move the decimal place one time. If I do that, it gives me 3.3. Remember, I can only have one number to the left of the decimal place. All right, well, I made this number smaller, so I got to make the exponent bigger. So that's going to give me an 8. So I think my answer for that would be 3.3 times 10 to the 8th. Okay. Any questions about that? Are there any questions about how I'm getting the exponent, how I'm getting the answer? Why I converted it from 33 to 3.3? Any questions? Okay, if there's no questions, let's talk about dividing. How am I going to divide? Well, the short answer is it's pretty much the same, except you're dividing. When you're dealing with the exponents, you're just simply going to subtract instead of add. That's the only difference, okay? So here in this problem, we have 6.92 times 10 to the 16th by 5.0 times 10 to the 13th. When we divide, we're going to divide the numbers in front normally, and we're going to subtract the exponents. So when dividing, subtract the exponents. When multiplying, add the exponents. Okay, let's do it. So we have 6.92 divided by 5.0, and that gives me 1.384. Okay, 1.384 times 10. Now, I'm dividing these, so that means I have to subtract the exponents. 16 minus 13 would give me 3. Okay, that's how I think we would do it. Okay, if we want to be really strict about rounding, which we just went over rounding, so sometimes we want to be strict, but I'm really only concerned with that right now. This is what I'm concerned with at the moment. But if we want to be strict about rounding, we had 2 decimal places here. We only had 1 here, so we really could only technically report 1. So this would be 1.4 times 10 to the third. Okay. But right now, I'm more concerned with how is the exponents working. Okay. I hope that makes sense. Please ask if there's some kind of confusion or there's anything weird going on. Let me know. Next, we have our fourth question like this. I want to divide 1.99 times 10 to the sixth by 4.20 times 10 to the first. Okay, the first step I do is I just divide the numbers in front normally. 1.99 divided by 4.20. What do I get? I get a whole bunch of stuff. I got a whole bunch of stuff. So I'm just going to have to decide how am I going to round. All right, I'm just going to round it. Well, maybe I shouldn't round too sloppily. I think I'll round to this 0. So I'm going to give myself a little bit of room to change. Let's go. Let's put a 1 there. That should be fine. Okay. Now times 10. And we're dividing in this question, so we have to subtract the exponents. This would be 6 minus 1. That's 5. Okay. Let me write that one more time. That's a 5. Okay, almost done. The next thing we have to fix is we have a 0 here. And we need to have a number other than 0 to the left of the decimal place. So this would be something like 4.7381 times 10. Now I made this number bigger by doing that, or you can say I moved it to the right. So I have to make this exponent smaller. Okay. So I believe that is the correct answer. But if we're worried about rounding or anything like that, where would be the appropriate thing to round? Here we have 2 decimal places and here we have 2. So I think we could safely say that this is 4.74 times 10 to the 4th. Okay. So when you are dividing, you subtract the exponents. When you multiply, you add the exponents. When you multiply the exponent, or when you multiply, you add the exponents. When you divide, you subtract. Okay. Multiply, add, divide, subtract. All right. Any questions about that?
I have a question.
Yeah.
What if your exponent is on this, like, okay, say 1.99 times 10 to the first divided by 4.20 divided by the sixth, 10 to the sixth.
What do we do? Because if we subtract, then it would give a negative answer. Is that what you're getting at?
Yeah, we minus the 1 from the 6.
So 1 minus 6 is -5. So it would be in that step, the exponent would be -5.
Okay, I think I understand that. What's
Okay.
the 2 little squiggly lines though in front of the 4.74?
It's approximate. So I'm just writing kind of equals approximate.
Okay. It's been such a long time since I've been in math, I didn't understand what that was.
Okay. So does what I did in this, does that make sense?
Yeah, this one makes sense.
Okay.
I was just
Okay.
asking, like, if it was the 10 to the first on the first part and 10 to the sixth on the second part.
What would happen? So that would be 1 minus 6, and that would give us a -5 for the exponent.
Okay.
Yeah. Okay. There's some comments. Yeah, so like Joe said, if the question was more complicated, it would be more complicated. So if the question was 1.99 times 10 to the first by 4.20 times 10 to the 6th, what would happen? So the exponent would become times 10 to the -5th. That's what would happen, okay? Because we'd be 1 minus 6. Okay. So that's if that's what it was asking. All right, hopefully the ones that I did make sense.